Good morning, dear students. Welcome again. Today, first of all, we shall revise when two miscible liquids are given in a solution, then what type of situation become create. So, today my first revision heading is vapor pressure of solution when the solute is a volatile liquid. Means what? Solute plus solvent is equal to solution. Solute is liquid and solvent become also said to be liquid. It means when two miscible liquids are given in a solution. For this, let us consider of two liquids, A and B, having mole fraction XA and XB at certain temperature, their partial pressure B, PA and PB, then according to Raoult's law, we can write what? PA proportional to XA. Similarly, PB proportional to XB. If we remove proportionality, PA is equal to P naught A into XA. Suppose this is our equation first. Similarly, PB is equal to P naught B into XB. This is equation second. What is PA? Vapor pressure of impure solvent. Vapor pressure of pure solvent. XA is called what? Mole fraction of liquid A. Similarly, PB means what? Vapor pressure of impure solvent, that is PB. P naught B, vapor pressure of pure solvent B. XB is equal to mole fraction of B. So, if solution become ideal, we can write PA plus PB is equal to P naught A into XA plus P naught B into XB. Suppose the sum of partial pressure is equal to P naught A into XA plus P naught B into XB. This is our main equation. When our solution become what? Ideal in nature. From equation third, we can write directly P is equal to P naught A plus P naught B minus P naught A into XB. Y is equal to mx plus c. This is a equation for what? A straight line. For XA, we can write what? 1 minus XB. xa is equal to 1 minus xb, because we know that the sum of mole fraction of solute and solvent become equal to what? Unity. This is supposed to be our equation number 4. Similarly, we can write P is equal to P naught B plus P naught A minus P naught B into what? XA. This is supposed to be our equation number 5. Here we can say the total vapor pressure is the linear function of mole fraction of component A. Total vapor pressure is the linear function of mole fraction of component X. So a straight line become obtained because satisfied the general formula of mathematics y is equal to mx plus c, when m is called what? Slope. So from previous equation we can write what? P is equal to P naught A plus XB P naught B minus P naught A. This is said to be what? Y. This one C. This one S. And this is said to be what? M. Y is equal to mx plus c. Said to be what? A straight line equation. Slope can be positive or negative. Positive when P naught B greater than P naught A, and negative P naught A is greater than what? P naught B. When this pattern of equation is satisfied, our solution become what? Ideal. Graph between vapor pressure and mole fraction. Suppose in this direction if we consider vapor pressure, and here mole fraction. This is said to be, suppose P naught A, here we can write P naught B, X is equal to 0, XB is equal to 1, here XB is equal to 0, X is equal to 1. PA is equal to P naught A into XA, PB is equal to P naught B into XB. This is P is equal to PA plus P. So if this type of curve become obtained, our solution become what? For ideal solution. We know that at x-axis y coordinate is considered to be 1 and x is equal to what? 0. Here just opposite, xp is equal to 0 and x is equal to 1. You have already learned when solution become ideal in nature. Our next revision heading is ideal and non-ideal solutions. Ideal and non-ideal solutions. Suppose two liquids, liquid A plus liquid B, mix together to form a solution. In this solution, three types of interaction forces are applicable: AA or BB and AB. If AA or BB and AB interaction forces are equal, then there is no deviation in the solution and our solution become what? Ideal in nature. There are so many conditions favoring for ideal solutions. So conditions for ideal solutions. First one, obey Rod's law, that is PA is equal to P naught A into XA and PB is equal to P naught B into XB. Second one, delta V mixing is equal to 0. Means what? The change of volume become equal to 0. Suppose here volume V1, here V2, then V1 plus V2 is equal to what? The volume of solution. Third one, delta H mixing also equal to what? 0. Means what? The change of enthalpy must be equal to what? 0. So such are the condition for what? Ideal solution. Examples, you can write benzene plus toluene. Again you can write carbon tetrachloride plus silicon tetrachloride. Normal hexane plus normal heptane. Such mixture always form what? Ideal solution. The next one, ideal solution can be divided into two parts. First one, you can write positive deviation, and second one, negative deviation. Means what? Positive or negative deviation do not follow Rod's law. For positive deviation, we can write what? PA greater than P naught A into XA and PB greater than P naught B into XB. This is said to be non-ideal solution. And negative deviation, PA less than P naught A into XA and PB less than P naught B into XA. Second one, delta V mixing greater than 0. Here delta H mixing greater than 0. In this way you can write what? Delta V mixing less than 0. Delta H mixing less than 0. shows minimum boiling azeotrophs. What are azeotrophs? We will discuss later. Here maximum boiling azeotrophs. So such are non-ideal solution. Means do not obey Raoult's law. Delta V mixing not equal to 0. Delta H mixing not equal to 0. If getter shows was positive deviation, if lesser shows what? Negative deviation. So that are the difference between ideal, non-ideal solutions. Next, we shall revise graph between vapor pressure and mole fraction for non-ideal solutions. Graphs. Suppose y-axis, if we consider vapor pressure, here mole fraction. For ideal solution, we know that what? A straight line become obtained. This is the resulting line. Suppose this point is P naught A. This one P naught B. Here x is equal to 1 and xb is equal to 0. Y-axis x coordinate is equal to 0. Here we write xb is equal to 0 and x is equal to 1. This is, suppose this pattern of curve obtained. This is said to be what? P greater than P naught A into XA plus P naught B into XB. Such curve indicate our solution become non-ideal, shows positive deviation. For positive deviation, example are, first you write acetone plus carbon disulfide, second ethyl alcohol plus water, always shows positive deviation. Similarly, we can say what? For positive deviation, we can write AA or BB interaction greater than what? AB interaction. If AA or BB interaction forces greater than AB interaction forces, then escaping tendency of vapor increases, which shows what? Positive deviation of Raoult's law. A and B is what? Liquid A plus liquid B mixed together to form a what? Solution. Similarly, if we draw the diagram between vapor pressure and mole fraction, suppose this is the graph for what? Ideal solution. Here again we can write P naught A, P naught B So if this pattern of graph obtained, here this one P less than P naught A into XA plus P naught B into XB, which shows what? Negative deviation of torso. For negative deviation, here we can write what? For negative deviation, AB interaction forces greater than AA or BB interaction forces. Examples are, you can write acetic acid plus pyridine C5H5N. The second example, you can write water plus HCl. Similarly, water plus nitric acid. Such mixture of liquid shows what? Negative deviation of torso. Here we can write Xa is equal to 1, Xb is equal to 0. Similarly, Xb is equal to 0, Xa is equal to 1. Such are the graph for positive deviation and here negative deviation. Our next revision heading is azeotropic mixture. When two liquids are mixed together and the boiling point after mixing become fixed and distill at a fixed temperature, then such mixture of composition is said to be what? Azeotropic mixture. So we can write next heading azeotropic mixture. Azeotropic mixture are the mixtures of liquids which boil at constant temperature and distill over without any change in composition. Suppose liquid first plus liquid second after mixed together to form a solution. Liquid A, water, BP 100 degree centigrade, ethyl alcohol, BP 78.3 degree. But after mixing, BP is equal to what? 78.1 degree. So after mixing, the BP either decreases from individual value or increases from individual value. This mixture is said to be what? Azeotropic mixture. Similarly, second one, if we write water and the second one HCl, BP 100 degree, here BP is equal to minus 85 degree. After mixing, BP is equal to 110 degree. This mixture is said to be maximum boiling azeotrope. This one minimum boiling azeotrope. Minimum boiling azeotrope shows positive deviation. Just suppose it. And maximum boiling azeotrope shows for negative deviation. Suppose if we do the graph between BP and mole fraction, this pattern of graph become obtained. This point indicate what? Minimum boiling azeotrope. But just opposite, suppose this pattern of graph obtained. BP mole fraction shows what? Maximum boiling azeotrope. So, in nutshell, we can say azeotropic mixture are the mixture of liquid which boils at constant temperature and distill over without any change in composition. For such mixture, the boiling point is fixed, that is 78.1 degree. Again, for this mixture, the boiling point is fixed, that is said to be what? 110 degrees centigrade. Then such mixture are called what? Azeotropic mixture. Our last heading is solubility of gas and liquid. Solubility of gases and liquids. That is, solute plus solvent is equal to solution. Solute exists in gaseous state and solvent in liquid state. When this pattern of mixture is given, then solubility of gas and liquid depends upon so many factors. Solubility of gases and liquid depends upon so many factors. The first important factor is what? Temperature. This pattern of solution is exothermic in nature. That is, gas plus liquid to form a solution, delta H is equal to negative. So according to Lewis principle, when temperature decreases, reaction move in what? Forward direction. And easy to form such pattern of solution. Second one, very important, pressure. Any gas when dissolved in liquid become partially soluble, but at high pressure it become highly soluble in water, which can be understood with the help of law known as what? Henry law. According to Henry, partial pressure of the dissolved gas is directly proportional to mole fraction. If we remove proportionality, give a constant kh into xg. This kh is equal to what? Henry law constant. When gas dissolves in liquid solvent to form a solution, for this pattern of solution, when temperature increases, our pressure decreases, because pressure is inversely proportional to temperature for such pattern of solution. So when pressure increases, temperature decreases. Ks directly proportional to T, and solubility is inversely proportional to K. So when pressure increases, our temperature decreases, temperature decreases, Ks decreases, then solubility increases. So when pressure increases, solubility of the gas in liquid solvent increases, which can be understood with the help of what? Henry law. If we draw the graph between partial pressure and mole fraction, then a straight line become obtained passing through origin. This is called what? Slope, that is kh. CO2 is strongly soluble in water because water is polar and CO2 is non-polar. So at high pressure, CO2 is highly soluble in water, which can be understood only on the basis of what? Henry laws. Our next factor is nature of gas, and last one, nature of liquid. If both are polar, then easy to mix to form such pattern of solution. Any gas which is easily converted into liquid, then a mixture become formed, said to be what? Solution. So such are the factors in which the solubility of gases in liquid solution depends. In next lecture, we will revise our new lesson, that is electrochemistry. Dear student, one thing always remember, you can ask any question or numerical from any part of the chemistry in the below comment box. I shall surely respond. Thank you.